very first thing I would like for you to make sure, and I think we put this into our notes yesterday, didn't we? Something like this, the different labels that we could use for Avogadro's number, right? Okay, so let's review this just slightly. Why did I use atoms for this top one here? Just a quick review. Why did I label that atoms? Michael? It's a single element, okay? So if I have a single element, I'm labeling it atoms. Right here. Why did I label this one molecules? Graham? It's covalently bonded. Excellent. So all covalently bonded substances, when I'm dealing with Avogadro's number, is molecules label. And finally, why did I label this one formula units? Okay, why did I label that one formula units? Emma? It's what? It is ionically bonded. Great. Okay. But one thing to notice, whether it's a single element, whether it's covalently bonded, whether it's ionically bonded, 1 mole of any substance has Avogadro's number of particles. All right? Now, I told you to copy this down in your notes. We are going to use this for what we call molar conversions. So we are going to be converting to different things. For instance, today, where it says down here at the bottom right, representative particles, that is dealing with Avogadro's number. So we are going to be using this section right here. Now notice that these arrows are pointing in different directions. Did you see that? Did you recognize? That's important, because when we did this earlier in a different class, they didn't realize that they had arrows there. Now, this is a chart that will help you understand how to convert using moles. Will you be able to use this chart on tests and quizzes? No. Okay. You will not. This chart is strictly a thought process visual for you. Kind of like the flow chart with naming, with our nomenclature. This is a visual that will help you convert. Now, when we do metric conversions, when we do these molar conversions, we're going to set up what I call conversion boxes. You need to make sure that you work these problems how I show you to work them. I still work them exactly like I'm going to show you. I've been doing this for 20 years, people. I still do it like that to prevent mistakes. Could you do it in a quicker way? Probably. Okay, but what you're going to see, we're going to use this later on in stoichiometry. So it's important to understand the process that I show you. Okay? Now, when we are doing a conversion, we set up something that I call a conversion box. Now, I'm going to switch this over. I'm going to get a new sheet right here. Where's my new sheet? There it is. Okay. I have a new sheet right here. I'm just going to do a simple conversion that we probably know. Okay? We probably know. I want to know how many donuts are in 3 dozen. Now I'm going to set up my conversion box, and my conversion box all deals with equalities and cancellations. Alright, so when I look at this, I'm going to say, okay, I want to know how many donuts are in 3 dozen. Well, you can already tell me because you know donuts, right? How many donuts are in 3 dozen? 36, because we know donuts. I really know donuts. I love donuts. Now, my conversion, though, is that every dozen has 12 donuts, right? That's my conversion factor. Why did I put one on the bottom, one on the top? Well, I look at this and I say, okay, this is like looking at 3 dozen is like being over 1, right? So what I want is I want my dozens to cancel. That dozen to cancel with that dozen. But let me ask you this. You guys know your math, right? What is a dozen over a dozen? That's 1, right? So that'll allow me to cancel my dozen label. Because I have 1 in the numerator, 1 in the denominator. So when I cancel that out, if I multiply 3 by 12, it gives me what? 36. What's my label going to be? What do I have left? Donuts. So this is 36 donuts. That's pretty simple, right? See, that's the thing. We can see donuts. Okay? We can visualize donuts. We can't visualize moles as well as we do donuts. Now, let's do another one here using our donuts. Let's do another one here using our donuts. I guess I can just clear this, can I? Clear my ink. Okay. Let me do another one using donuts. I have 437 donuts. And I want to know how many dozen that is. So now, what I'm doing is I'm going to set up another conversion box. The only thing is, what do I want to cancel? What do I want to cancel? Donuts, right? So where am I going to put that? On the bottom. So I'm going to put my 12 donuts on the bottom, and on the top I'm going to put 1 dozen. This is my equality. That's my equality. I know that in 1 dozen donuts, in 1 dozen, I have 12 donuts, right? Those are equal. I get my cancellation to occur because I have donuts on the top, I have donuts on the bottom. So what's my label going to be? Dozen. My label is going to be dozen, but I need to figure out my number. Now, when I'm doing this, okay, when I'm doing this and I'm using my calculator to calculate this, I look at this, 137 times 1. What's 137 times 1? 137. So if the number's on the top, I multiply it. If the number's on the bottom, I divide it. So I'm going to take 137 times 1 excuse me, 437. 437 times 1 to give me 437. And I'm going to divide that by 12 because that's on the bottom. And I get 36.416. Now, I don't have significant figures. In this case, I would have my sig figs be 2 because I have 12, so it would be 36 dozen. But I just wanted to show you that it's not exactly 36 dozen. Did you see how I did that? Okay. Now, I'm going to come back over to this, and this is what I call the flux capacitor. Okay, anybody seen Back to the Future ever? The DeLorean? The reason that the DeLorean could go back in space was the flux capacitor. Well, it kind of looks, the flux capacitor kind of looked like that. So I just named this the flux capacitor. So when you hear me talk about the flux capacitor, I'm talking about this. But I had you write this down in your notes because I'm going to show you the equality between moles and representative particles. Okay? So if I am right here, if I have a mole and I'm going to try to get representative particles, I set up a conversion box. That has Avogadro's number on the top of the conversion box and the mole on the bottom of the conversion box. So I would write that in, and it's going with the arrow from mole to representative particles. So it's going with the arrow from right here, this arrow going down. Well, if I'm converting the other way, if I'm converting with my gold arrow here, going up, I'm using that arrow going up right there, my conversion box is going to be the same thing inverted. I'm going to have one mole on the top. I'm going to have Avogadro's number on the bottom. Now remember, Avogadro's number can have the 3 different labels, right? It can have the 3 different labels. So, let's, just for giggles, folks, let's just jump right on in. Write this down. Copy this. Now that you have this copied down, let's look and say, okay, how many formula units are in 2.84 moles of barium chloride? Now, when I'm looking at this, what value did they give me? What was the label of my value that they gave me? Moles, right? What am I trying to find? Formula units. So if I look on my flux capacitor, I'm starting out in the mole box. I'm starting right here in the mole box. So I am going to convert to representative particles because that's what a formula unit is, isn't it? So I am going to use this part of my conversion box right there. So I'm going from moles to representative particles. So as I come back and do this, I'm going to write 2.84 moles. What is barium chloride? BaCl2. Once again, I like doing that just to test you, to see if you know your formula writing. Now, my conversion box, where as I was going down, and I can see right here, what do I want to convert? What do I want to cancel? Moles. So where's that going to end up? On the bottom, right? So I know that 1 mole of barium chloride, and I'm now including labels on these folks. 1 mole of barium chloride has Avogadro's number formula units of BaCl2. That's hard to read, but that's formula units, BaCl2. Now I look. Does my unit cancel that I want to cancel? Well, here's a mole of barium chloride in the numerator, a mole of barium chloride in the denominator. So now, that cancels. What label am I left with? Formula units, BaCl2. So what are you going to do in your calculator? You're going to multiply. So go ahead and do that. 2.84, and I'm multiplying that by Avogadro's number. Hopefully you remember how to program Avogadro's number into your calculator from the other day. And I get 1.71 times 10 to the 24 formula units of barium chloride. Now, I had a big long number, 1.710248 times 10 to the 24. Why did I only put 1.71? I had to round it to the number of significant figures, which in this case is 1, 2, 3 sig figs. So that's why I have 3 sig figs. 1, 2, 3 in my answer. What do you think? Okay? Yeah, Carly? No. To the 0 in my number? No. No. This has 3 digits in it. 1, 2, 3, right? Those are 3 significant, so I go 1, 2, 3 significant there. Okay? I have a video on sig figs on my website if you need to review those. Come up and ask me, I'll show you the link to it. Now, let's try another example. So I will give you a second to write this down, write this question down. Our second question was how many moles are in 2.02 times 10 to the 52nd atoms of iridium. So in terms of our flux capacitor, where are we starting at? Given to me as atoms, which is a representative particle, right? So I am starting here. Representative particles, right? Where am I going? I'm trying to find moles, right? So I'm following this yellow arrow right here. So my conversion box is right there. So I take 2.02 times 10 to the 52nd atoms of iridium. I make my conversion box. What do I want to put on the bottom? Avogadro's number atoms of iridium, and on the top, 1 mole of iridium. Do I get my labels to cancel? That's one thing I always check, that I need this label to cancel that label, and it leaves me with the label mole of iridium. So what am I going to do with my calculator, people? Huh? Divide it. So, I'm going to take 2.02 times 10 to the 52nd, and I'm going to divide it by 6.022 times 10 to the 23rd, and I come up with 1, 2, 3, 6, so I'm going to have 3.35, and don't forget the times 10 at the back end in your calculator, times 10 to the 28th. Agreed? Okay. Now, as you can see, I've got a bunch of examples here. Let's go ahead. What I want you to do is write this one down, and this will be the first thing we do tomorrow. I want you to write this down, and I want you to work this problem tonight. And that's how we will start class tomorrow, by working this problem.